For example 7, we have sine alpha, which I've drawn in red there, and we have cos beta, which I've drawn in blue. And we're given sine alpha is root 40 over 7 in quadrant 2. So notice that the vertical is root 40, the hypotenuse or the radius is 7. And I've drawn that in quadrant 2. And in the blue, we have the cosine. So the horizontal is negative 4, and the hypotenuse or the radius is 5. So we're being asked to solve for the exact value of sine of alpha plus beta. So as soon as I see that the plus in here, there's only one way to do it. We have to apply the sum angle identity, which is from my formula sheet. So I go to my formula sheet right away. So it's sine alpha. Maybe just going to color code this. There's alpha and beta. So it's going to be sine alpha. So I need to go to the alpha picture. Cos beta. So for that, I need to go to the beta picture. And then I have sine beta, cosine alpha. Okay, so when I want sine alpha, I need to go, I don't have a picture for alpha plus beta, so I need to use this identity. And when I see sine alpha, now I have a picture for alpha, so I'm going to use that picture to find sine alpha. So I'm just going to replace that whole sine alpha, okay, with root 40 over 7. And please do not write sine root 40 over 7. So this means nothing. So don't ever write something like that. We just replace the whole sine piece with the root 40 over 7. For beta, cos beta, I go to my beta picture, my blue picture, and the cosine is going to be negative 4 over 5 plus. I need sine beta, but for my sine beta, I need the vertical side of this triangle. So using Pythagoras, 5 squared minus negative 4 all squared is going to give me 16. So that's going to be square root 9. And so that third side is going to be positive 3 because it's going up. So now I can replace the sine beta with 3 over 5, positive 3 over 5. And again, we're not writing things like this, sine 3 over 5. This makes no sense. That is a ratio inside a ratio, which we can't do. And then lastly, I go to my cosine alpha. I need the third side here, so I'm going to use Pythagoras again. So 49 minus 40 is 9, and that gives me 3. But since it's going to the left, I need to make sure I have the negative 3. So cosine alpha from the red picture is going to be the horizontal over my radius. Okay, so once I've plugged it all in, I just need to work that out. Okay, I get negative 4 root 40 over 35, and you should notice that we end up with a common denominator here. So we end up with negative 9, and we just combine those numerators because the denominators will tend to be common denominators. So negative 4 root 40 minus 9, and that's all over 35. There's my final answer. That's exact value.